to simplify algebraic expressions, we have to combine like terms. Like terms can be identified because they are going to have the same variable, and that variable will be raised to the same power. Constants, which are terms that do not have variables, are all going to be like terms to each other because they can be combined at any time. So let's look at this list and try to find some like terms. The first term on our list is 5a. If I need to find a like term for 5a, then I need to find another term that has the variable a. I notice that this term has the variable a, 6ab, but because it has this b with it, that's not a like term for 5a. So now I'm going to keep going on my list. I have 12 and then I have 4a. Well, 4a and 5a are like terms. So I have 5a and 4a, and now we can see if there's anything else. Next I have 9b, that's not a like term. But then I have 3a to the second power. Again, this has an a, but it is not a like term with 5a and 4a because this second power tells us that I'm taking a and raising to the second power. So it would not be considered a like term. Then I have 7ab, 28.4, 10b to the second power, 8b, and a to the second power. None of those are like terms with 5a and 4a, so these are the only two like terms for that. Now let's look at 5b. To find like terms for 5b, I need to find terms that have a b as the variable, and that's it. So 6ab has the b as a variable, but it also has a, so it's not a like term. Then 12 is a constant, so it's not a like term. But then I have 9b, and that does have b for a variable, and that's it. So I know that I have 5b and 9b that are like terms. And then I have 3a to the second, 7ab, 28.4, 10b to the second. Again, this has b, but this second power means that it's being raised to a different power, so they're not like terms. Next, I have 8b, and this does have b, so this is also a like term. So 8b, 5b, and 9b are all like terms. Next, I have 6ab. So I'm looking for any term that also has a and b as the variable. So this does not, 3a to the second does not, but then 7ab does. So 6ab and 7ab are like terms. Next I have 12. I notice that 12 does not have any variables with it, and that's because 12 is a constant. All constants, which are terms that do not have variables, are considered like terms. So I'm going to look for any other term that also does not have a variable. So 3a to the second has a variable, so it cannot be a constant. And then 28.4 does not have a variable, so 28.4 is a constant. So that means that 12 and 28.4 can be combined. They are like terms. Next, I have 3a to the second power, so I'm looking for any term that has a being raised to the second power. So my next term on my list is 10b to the second power. Well, this has b being raised to the second power, so the variable is different, but the power is the same. Because the variable is different, they're not like terms, even though they have the same power, so they cannot be like terms. So now I'm going to go to the next one on my list, which is a to the second power. Now this does have the same variable, they both have the variable a, and they both have a being raised to the second power, which means that 3a to the second and a to the second are like terms. And finally I have 10b to the second power, and if I look on my list, there's nothing else available on my list, which means that 10b to the second power does not have a like term in that list. So now that we know what like terms are, we can simplify them or simplify expressions by combining like terms. So in this expression, I have 17m minus 10m. I notice that they are like terms because they both have the variable m, which means that all I have to do is combine their coefficients. So this would be like saying 17 minus 10. Well, 17 minus 10 would give me 7, but because it's 17 m's and I'm taking 10 m's away from that, I'm left with 7 m's. Next, I have 8xy plus 5x plus 3xy. Remember, I can only combine things that are like terms. So if I start with my first term, I have 8xy. So if I'm going to be able to combine something, I have to be able to combine something that has both an x and a y. So 5x has an x, but it does not have a y, which means it is not a like term with 8xy. And then 3xy has both the x and y, so these are like terms. So I can combine 8xy and 3xy, and I look at the plus sign in front of 3xy, and that tells me that it's being added. So I'm going to do 8xy plus 3xy, and 8 plus 3 gives me 11, so this is 11xy. Now, when I've done that, I've gotten rid of 8xy and 3xy, and the only thing I'm left with is 5x. 5x does not have a like term, but that doesn't mean that it can be ignored. So to simplify the expression, I need to bring that plus 5x down. So my simplified expression would be 11xy plus 5x. Next, I have 9a plus 15 plus 6a minus 3. So I'm going to start with my first term, which is 9a, and I'm going to look for any like terms. I know that 15 is not a like term because it does not have an a, and then I see 6a. Well, those are like terms because they have the same variable raised to the same power. The plus sign in front of the 6a tells me that I'm adding, so 9a plus 6a gives me 15a. Now I've gotten rid of 9a and I've gotten rid of plus 6a. Now I'm going to look at my next term, which is 15. 15 is a constant because it doesn't have a variable, so I'm looking for any other constant in this expression. I notice that I have this minus 3 here, which is also a constant, and this subtraction sign in front of the 3 tells me that it's being subtracted. When I do 15 minus 3, I get 12, and I know that 15 minus 3 is positive 12, so because it's positive, I would write plus 12. So my expression would be 15a plus 12, and that is the most simplified that expression can get. I cannot put 15a and 12 together because they are not like terms. Next, I have 13b plus 4ab plus 6a minus 2ab plus 5a. So we're going to find all of our like terms. My first term is 13b, and when I look, I notice that I have 4ab, 6a, 2ab, and 5a. None of those have a variable of just b, which means 13b does not have a like term. So when I'm simplifying my expression, I'm just going to rewrite 13b because it has nothing that it can be simplified with. Now I'm going to go to my next term, which is 4ab. So I'm looking for a term that also has ab, and I notice that I have 2ab right here. The subtraction sign in front of 2ab tells me that I'm subtracting. So 4ab minus 2ab is 2ab. Now that's a positive 2ab, so I would write plus 2ab, and these are going to go away because they have been combined. Next I have 6a, and then I notice that I have 5a. They have the same variable raised to the same power, so these are like terms. The plus sign in front of 5a tells me it's being added. So 6a plus 5a is 11a, so plus 11a. So my simplified expression is 13b plus 2ab plus 11a. Next I have 4x squared plus 7x minus x squared plus 10 plus 2x minus 5. So let's look at our first term, which is 4x squared. We're going to look for a term that also has x that is being raised to the second power. So 7x has the same variable, but that variable is not being raised to the second power, so they are not like terms. But then I have x squared, which does have an x that is being raised to the second power. Well, the minus sign in front of this tells me that I'm subtracting, and I need to subtract my coefficients. Well, we need to remember that when we don't see a coefficient in front of a term, that actually means, or in front of a variable, that actually means that there's an invisible 1. So this is like saying 4x squared minus 1x squared, and that would give us 3x squared. So now these will go away because they have been combined. And now let's look at our next term, which is 7x. I notice that I also have 2x over here. They are like terms because they have the same variable raised to the same power. The plus sign in front of 2x tells us we're adding. 7x plus 2x gives us 9x, so we'll write plus 9x, and now we're going to get rid of these because they have been combined. Next we have 10, which is a constant, so we're looking for anything else that does not have a variable, and we notice that 5 is also a constant. The subtraction sign in front of 5 tells us that we're subtracting. 10 minus 5 gives us 5. Now that's a positive 5, and because it's positive, we're going to write plus 5. So our simplified expression is 3x squared plus 9x plus 5. Finally, we have 3 times 2x plus 5 plus 4x minus 2. In this expression, you'll notice that I have a multiplication problem. This would require me to use the distributive property before I could start simplifying. So the first thing I would need to do here would be to distribute my 3 to 2x and to 5. If I multiply 3 times 2x, that gives me 6x. And if I multiply 3 times 5, that gives me 15. So this part can be simplified to 6x plus 15. But you'll notice that I still have plus 4x and minus 2 at the end of my expression, and I need to rewrite that. Now I need to check and see if there's anything that can be simplified, so I'm going to check for any like terms. I notice that I have 6x and 4x, and there's a plus sign that tells me to add. So 6x plus 4x gives me 10x. So now I've combined 6x and 4x, and now I still have 15 and 2. They are both constants, so they are like terms. The subtraction sign in front of 2 tells me to subtract 15 minus 2, which gives me 13. Now that's a positive 13, so I would write plus 13. And my simplified expression would be 10x plus 13.